Welcome back. In the previous session, we were talking about the types of data integrity controls, in that we discussed the hashing algorithms. In this session, we'll try to discuss the salting, is another way of doing the hashing or data integrity control. So, what is salting? Salting makes password hashing more secure. If two users have the same password, they will also have the same password hashes. So you can see here. So a salt, which is a random string of character, is an additional input to the password before hashing. So this creates a different hash result for the two passwords as shown in this figure. You can see here. So you can find two different hash values. So this salting is providing, some additional strings or the random string of these characters which are adding to the value that password hashing. So a database stores both the hash and the salt, the hash as well as the salt also. So in this figure, you can see the same password generates a different hash because the salt in each instance is different. So the salt does not have to be secret since it is a random number, right? So then how this salting is used to preventing the attacks. So salting prevents an attacker from using a dictionary attack to try to guess passwords. Salting also makes it impossible to use lookup tables and rainbow tables to crack a hash. So we'll see what is lookup tables and the rainbow tables. A lookup table stores the pre-computed hashes of passwords in a password dictionary along with the corresponding passwords. A lookup table is a data structure that processes hundreds of hash lookups per second. So you can click here to see how fast these lookup tables can crack the hashes. You can use this link for more explanation and more understanding about lookup tables. So there is a reverse lookup tables that you can find. So reverse lookup tables is this attack. This reverse lookup tables is an attack. So this attack allows the cyber criminals to launch a dictionary or brute force attacks on many hashes without the pre-computed lookup table. So the criminals creates a lookup table by themselves that plots each password hash from the breached account database to a list of users. So the cyber criminal hashes each password guesses and uses that lookup table to get a list of users whose passwords matches the cyber criminal's guesses. So, as you can see in this example, for searching in this diagram, you can the searching for the hash password with these cyber criminals. If anything is matching, then it will give the correct password. If not matching, then it simply announces that no users used that guessed password. So, since many users have the same password, the attack works well sometimes. So this is the reverse lookup table. So we talk about the rainbow tables. So in the rainbow table, this rainbow table sacrifice the hash cracking speed to make the lookup tables smaller. A smaller table means that the table can store the solutions to more hashes in the same amount of space. So, this is, as said, this salting prevents an attacker from using the dictionary attack to try to guess these passwords. So the salting also makes it, as said, it is impossible to use these lookup tables or rainbow tables to crack the hashes. Okay, that is the beauty of salting. Another, will dive into the implementing part of your salting. Let us see that how to implement this salting. So, to implement this salting, a cryptographically secure pseudo random number generator is the best choice to generate salt. That's CSR. So, this cryptographically secure pseudo random number generator CSPRNG, this generator generate a random number that has a high level of randomness and is completely unpredictable, so it is cryptographically secure. To implement salting successfully, we use these following recommendations. One is the salt needs to be unique for every user password. Second recommendation is never reuse a salt. Third recommendation, the length of the salt should match the length of the hash function's output. And always hash on the server in a web application. So using a technique called keys, stretching will also help to protect against the attack. So the key stretching makes the hash function very slowly. So this prevents high-end hardware that can compute billions of hashes per second less effective. So the steps a database application uses to store and validate a salted password are as shown in this diagram. So to store a password, as said, it uses the cryptographically secure pseudo random number generator CSPNGR, which generates a long salt, and it adds a salt to the beginning of the password, then hash it with the secure hash algorithm 256 bits. That is, the digest size is 256 bit, and this is a standard cryptographic hash function for the web applications, and save the salt and the hash as part of the user's database record. So when it is going for the validating this password, it retrieves the user's salt and hash from the database, add the salt to the password and hash it with the same hash function, that is secure hash algorithm 256, and compare the digest or the hash value of the given password. If they are matching, then the database, the user can grant, user will be granting access, or not, there will be a misgranting it. So by keeping this information in your lab for password cracking, use the password cracking tools to the recover a user's password. Right. With this, I'd stop this salting. In the next session, we'll try to talk about what is and the HMAC.